Your exam is going to cover everything up through 4-6. We will do 4-7 and 4-8. There's kind of a natural break there anyway, so we'll do 4-7 and 4-8 after Christmas. We will then have a massive Chapter 4 test after Christmas. So I'm sorry we're just kind of splitting it, but I did spend my time in Loretto subbing, working on some review materials for that. So your exam goes up to 4-6. We, in this class, will be having a quiz over 4-4 to 4-6 when we finish. I'm not sure what day that's going to be yet, but we'll have a quiz over 4-4 to 4-6. I am preparing your review materials for the exam, so the day we have the quiz, I will give you the review materials. I've already put some on Schoology. I already have some review materials in there, but those are old ones. I've got to revise a few things because this exam is going to cover a little bit different material. So we're going to have one more quiz, 4-4 to 4-6, and then we have our exam. And then we have, after Christmas, we'll start the quarter with some Chapter 4 stuff, but probably the second or the beginning of the third week back from May term, I should say, we will do a Chapter 4 test and then continue plowing ahead with everything. Okay? So everybody knows what's up. All right, so we're in our notes, page 52. We're ready to do number 6, which is the Ferris wheel problem. By the way, homework 4-4 will be due on, what's today? Tuesday, Thursday. 4-4 is going to be due on Thursday. Mark your calendar. You might want to take a look at that and come in for office hours if you need help. It's a little bit tricky. Some of it is. Okay? All right. A Ferris wheel 50 feet in diameter makes one revolution every 40 seconds. So, Liam, you're now here. So, let's talk about that. What does that 40 seconds represent? How long it takes to make a revolution. So think about, in a minute, well, let's just do it right now. Let's graph the path of this Ferris wheel. So, let's see, I'm going to draw my Ferris wheel right here. So here's the Ferris wheel. It's 50 feet in diameter, so that means the radius is 25. The center of the wheel is 30 feet above the ground, which means this here is 5. Does that make sense? So if you're on the Ferris wheel, the lowest you get is 5. So when I get on the Ferris wheel right here, I'm at 5. And then the Ferris wheel starts going around. So I go up, and then don't I come back down again? And when I come back down, I'm also at 5. What's my highest point? That is my height above the ground. At my highest point is going to be what? 55. Because we're 5 and then 50, right? When we're at the top. So do you see a cosine curve there? Of the height of the person above the ground? Yeah. Now, back to my original question. What does the 40 represent? Isn't that this right here? In other words, isn't the period 40 one time around? So the period of the curve is 40 seconds. And, okay, what's the amplitude? This is a cosine curve. Okay, I know it's a cosine curve. That shape is cosine. What's the amplitude? Remember, the amplitude is the height of the wave or the depth of the valley, whichever it is. And Lewis says the amplitude's 25, is he right? But if I'm writing this equation, I better make that a negative, because why? The curve is upside upside down, right? What do cosines look like normally? Start up here, go down. This one's starting at the bottom, so it's a negative cosine curve. Does it have a phase shift? So when I think about filling in a blank here, does it have a phase shift? No, that's just gonna be a plain old X. Because isn't it starting right where it's supposed to, on the axis? Does it have a vertical shift? In other words, is there a number on the end of it? Yes, there is. Be careful. Its vertical shift isn't 5. Its vertical shift is, what's this right here? No, it's not 25. It's halfway between 5 and 55. Aren't we 30 feet above the ground? I mean, isn't that axis 30 feet up? So that's a plus 30. Now, this number right here, I don't know what it is. But I know that whatever it is, I'll call it n for the time being. Whatever it is, it divides the period, right? Or divides the normal period. What is the normal period for a cosine? 2 pi. So my period is 40, which is 2 pi divided by this number. That's how you find period. It's 2 pi for a cosine. It's 2 pi divided by this number. So what would that number have to be? If 2 pi divided by it is 40, that number, no, watch your arithmetic, 2 pi over 40, which is pi over 20. So this number right here is pi over 20. Because 2 pi divided by pi over 20 would give me 40, right?
Is the
Okay.
25 from the little circle diameter thing?
This 25?
Yeah.
No, it's half the height.
So
Or, I mean, not half the height, it's the actual height of the hill. Half the distance from the top to the bottom.
or what's the average?
That's
Because
the
when
new
you
axis.
typically I thought add the 2 then divide by 2.
Okay, when I add these and divide by 2, I get 30,
Right.
which is the middle point. That's my new axis. This is the amplitude.
Between 30 and 50.
Yes. So here's my equation. So now I'm ready to answer any questions that come out of that. All right, so here we go. If the sun, how long after reaching the low point is a rider 50 feet above the ground? So here's your equation. We need to figure out when we are 50 feet above the ground. So what do you think we should do? For y. We're gonna plug in 50 for y. So here we go. 50, this is gonna be a calculator problem, by the way. Negative 25 cosine pi over 20x plus 30. There's my equation. So what do you think I should do first? So minus 30, so I'm gonna subtract 30, so I get 20 equals negative 25 cosine pi over 20x. Okay? Now what? Divide by negative 25, so what is that? Negative 0.8 equals cosine pi over 20x. Now let's not be frightened, okay? Do not be afraid of this equation. You can do this. Suppose it said cosine x equals negative 0.8. Just suppose that's what it said. Tell me what you know about that angle. If the cosine is something negative, where does that angle have to be? In which quadrant? What quadrants, I should say? Second or third. Sydney, how did you know that?
Because if it's in the first quadrant, both are positive, and fourth, both would be negative.
No. Third,
Yeah.
they're both negative, but I'm not concerned
yeah,
about both.
sorry.
I want, if I'm doing cosine, I care about x, right? Adjacent. And if you think about drawing your triangles, isn't this where the adjacent side is negative? X. Cosine is x. So I have angles in quadrant 2. I'll just start with that one. Quadrant 2. How do I find what that angle is? Now back just doing this. That complicates it a little bit, but not much. How do I find what that angle is? On my calculator. What buttons do I have to press? First of all, I need to be in radians. So I'm going to go to mode, make sure I'm in radians. And then I will second cosine, negative 0.8. So second cosine, negative 0.8, tells me that this angle right here is 2.4, I'll say 2.50. Did everybody else get that? Second cosine, negative 0.8. It sets me right over here. In this quadrant, it's 2.50. Now that means that whatever this is, I don't know what that is, but the cosine of 2.50 is how I get negative 0.8. So whatever this is, pi over 20 has to equal 2.50. 2.50 is the angle that gives me the cosine I want. So 2.50 times 20 divided by pi, 15.9. So that means at 15.9, I am, how high was I trying to be above the ground? I'm 50 feet above the ground. This is where I'm 50. At 1 point or 15.9. Now, remember Sydney said there were 2 answers? Am I 50 feet above the ground someplace else? That would be right here, right? But the question doesn't ask me for both. It says, what is the first time I'm that high above the ground? And if I typed in everything correctly, that would be 50. I don't know, 15.9. Okay? Sydney?
Sorry, really quick, one more time. Why, how do you know it's 5 off the ground? Like, 55 and 5, how is it 55 and 5 as opposed to 50 and 0?
Because it says the diameter of the wheel, I erased my picture, but the diameter of the wheel is 25. But it says that the center of the wheel is 30 feet above the ground.
Okay, so there, okay.
So do I need an extra 5 in here? Yeah. Tess?
I'm pretty certain where'd you get cos of x from? Yeah.
No. This says the cosine of some angle is negative 0.8. Forget what we call it. The cosine of some angle is negative 0.8. So I have to figure out what that angle is. And then I'll go back and say, okay, if the angle's name is pi over 20x, then pi over 20x has to be that angle. It has to be 2.5. So what does that make the x in the problem? 15 point whatever. Okay? All right, one more. Okay. I think this next one, I think they already told us the equation. We got a signal buoy bobbing up and down, and its equation, A sine BT plus 5. Okay, well, they don't actually tell us. We gotta build our own equation. Okay? The height above the ground is given by this formula. During a small squall, the height varies from 1 to 9. So I want you to think about that for a second. The height of this curve, it's a sine curve, for argument's sake. Well, the height varies from 1 to 9. 1 to 9. So that means the lowest point is 1 and the highest point is 9? Now that's not a sine curve, but anyway, you get the idea, right? So if the height is varying from 1 to 9, then what does that tell me about the amplitude? The A value there. It's gotta be 4. Because top to bottom is 8. That means bottom of valley to top of hill is 8. So how big are the hills? 4? So I know my A is 4. So let me draw a better picture here. It's actually a sine curve. Here we go. So it's going up to 9 and down to 1. Now, oh wait, the amplitude isn't 4. The amplitude is 4, but this middle number isn't 4. This middle number is 5, which they already gave me. Did they give me that, or did I type that in? Nope, they gave that to me. I could figure that out though, couldn't I? Yeah. All right, so the amplitude is 4. The height of the waves, depth of the valley is 4. The only thing I don't know is what this V is. I do know that 2 pi divided by that B is how I would calculate my period. That's how you find the period of a sine or cosine. 2 pi divided by that number. So what did they tell me? Did they give me any information about it? There are 3.5 seconds from one 9 to the next 9. Isn't that a period? So 2 pi over B equals 3.5? Or 2 pi over B equals 7/2, that's what I'll do. So 4 pi equals 7B, B equals, did you get 4 pi over 7? So this number right here is 4 pi over 7. Remember, that number is not the period. This number is not the period. This number gives you the period. 2 pi divided by it gives us the period. Okay, so is there a question? Yep, what are the values? We already did it. Already did it. So, if we wanted to know how high the waves were at 1 second, we would just plug in 1. If we wanted to know when are the waves, I don't know, 4 feet tall, we would plug in 4. Good, 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 good. Okay. Good thought-provoking stuff there. Please remember, amplitude is the height of the wave. Or you can think about it as half the the distance from the top to the bottom. That's the amplitude. From 1 to 9 is 8. Half of that's a hill, half of that's a valley, so 4 is the amplitude. This number, all it does is help me find the period. 2 pi divided by it is the period of the curve. Anything, I don't have it this time, but anything directly added or subtracted to the x, or the t in this case, is your phase shift, horizontal shift, giving you your starting point. And then anything added or subtracted to the end is your vertical shift, what you up and down move. So we're going to need all of that as we proceed through this next section, where we are graphing the secant, cosecant, cotangent, tangent. So, what do you know about the cosecant? Reciprocal of sine. So, I'm older than the hills. I've done this, I do this for a living. I never graph a cosecant without graphing a sine first. I have sine memorized. It's one of my BFFs. I know its amplitude is 1 and its period is 2 pi. This is my normal, this is my normal sine curve. Would everybody agree with that? If you don't already kind of have that memorized, get it memorized. You should be able to crank out sine curves with your eyes closed. This is normal. I don't have any numbers in the problem at all, so it's standard curve. You just told me that the cosecant is the reciprocal of the sine. So what that means is the cosecant values, I'll do this in purple, the cosecant values are going to be the reciprocal values of the sine. I want you to look right here. The value of the sine is 0. What is the reciprocal of 0?
Undefined.
Undefined. 1 over 0. That's the reciprocal. So undefined is graphed like it always is. Think back to chapter 2 or whatever that was. Vertical asymptotes. Wherever the sine is 0, the cosecant is going to be undefined. Agreed? And undefined means vertical asymptote. Cannot be. So, guess what? We're going to have another one here. We're going to have another one here. And if we continued our sine curve, we just keep having them. Now, what's the value of the sine right here? The actual sine value here is 1. What's the reciprocal of 1? 1. So that point is right there. What about this one? Still there? Because that's -1, and 1 over -1 is still -1. All right, let's get creative here. Right about here, the sine is 1/2. So its reciprocal would be 2. So its reciprocal is going to be up here, right? Won't the same thing happen here? What do you think's going on here? What's that look like? It looks like a parabola. This hill gets reciprocaled, flipped up, and it becomes a parabola. What happens to this one? Same thing, only it goes down. The purple thing is a picture of the cosecant. So the good news is, if you know how to graph sine equations, you can do these, because you just drop in asymptotes and flip the parabolas and you got it, right? You got it. Now, one big thing to talk about here. What is the amplitude of our sine curve? Our regular straight sine curve has an amplitude of 1. The cosecant has no amplitude. Because why? Tell me why the cosecant has no amplitude. There's no top. Amplitude is half the distance from the top to the bottom. You don't have a top or a bottom. It goes on infinitely. In fact, you'll see here in a second, sine and cosine are the only curves with amplitude. None of the rest of them have amplitude. Only sine and cosine. Marin?
So the first part of the cosecant graph, so the opposite, you took reciprocal of 1 is 1, and that's that purple point, the bottom point.
Yep.
And the top 2 points, did you get?
I took the reciprocal of a half, just randomly. Because here it's a 1/2. So the reciprocal would be 2.
Not 2 over 5?
Not what?
2 over 5?
Okay, wait. These are x values. I'm doing y values. The cosecant is the reciprocal of the sine. So the y value, the sine value right here is 1/2. The reciprocal of 1/2 is 2. The x values are staying the same. I'm not doing anything with the x values. Y is the value of the sine on the black curve. Y is the sine value. So you take the reciprocal of the sine values. Take the reciprocal of the y's.
What would
Sabrina?
the period and frequency be?
Well, you tell me. What's the period of this curve?
Is it 2 pi?
Of course it is, right? We didn't change that.
Well, it's not really consistent, like it's not
Well,
much.
yeah, it is. Because what does period mean? Period means the length of the curve this way, one full thing. So what happens, I've got my parabola up and my parabola down. What happens if I continue going? What am I gonna have? Another parabola up and another one down. It just keeps repeating,
So
right?
what would the frequency be?
The reciprocal of the period.
So 1 over 2 pi?
Yep. Probably if you sat up.
I'd be able to see better.
Yep. That blood might flow to that brain. All right. All right, next, I'm gonna graph the secant, okay? How do you think I'm going to graph the secant? Same thing, only I'm gonna start with a cosine, right? So here's my regular straight cosine curve. And again, you should be able to do this with your eyes closed, and you can certainly continue it as far as you want. You really only need one period. I'm only gonna ever ask you to graph one period, which would be, I'll go ahead and darken in, here's 0 to 2 pi, which is considered the standard period, because 0 to 2 pi is once around the circle, one revolution. So this black solid is like the normal regular period, but it goes on forever and ever and ever. Secant, being the reciprocal of the cosine, will be undefined when? Whenever the cosine is 0. So where is the cosine 0? Right here? So I'm gonna have an asymptote there. Gonna have an asymptote here. Now, in the normal regular period, that's it. Will there be other asymptotes in the picture if I kept going? Yep. Now, this one's the easiest to see. What do you think's gonna happen between these two asymptotes here? When I do the reciprocal, isn't the parabola just gonna flip over like this? It's just like that. Except it's a little more convoluted here because if this is all I have, when I flip it, I'm gonna get back, which is only half a parabola. because the other half is over here. So that's why sometimes it's easier to visualize the whole thing so that you see it's still the same parabolas. They're just shifted. Because the sine and cosine are the same curve, just shifted. So does the secant have amplitude? No, there's no top or bottom to this thing. That is a secant. Tangent and cotangent are different animals. So here's what I would like you to do. First of all, what's our circular definition of tangent? Don't say opposite over adjacent. What's the circular definition? Y over x. Perfect. Then I want you to draw your handy dandy unit circle. And I know in the book, or in the notes, I copied out of the book with all those values. Just look at the quadrantal ones. So just the ones that are on the axis. Keeping in mind that this is 0, pi over 2, pi, 3 pi over 2, and 2 pi if I go around. Right? Remember all the way around is 2 pi? So halfway is pi, this is pi over 2, this is 1.5 pi's. So here's my axis, it's that here. Tell me what happens to the tangent. I don't know why I put y, that's tangent. Tell me what happens to the tangent at 0. So here's your point, I'm at 0. What is the value of the tangent? 0. So right there it is, 0. At 0, my value is 0. The next angle is pi over 2. What happens to the tangent at pi over 2? It's undefined. How do I do that? Vertical asymptote. If you type tangent pi over 2 or tangent 90 on your calculator, it will say impossible. There isn't a tangent. All right, what about our next angle, which is pi? What happens over here? 0 again? All right. What about 3 pi over 2? What happens down here? Undefined again? I don't know about you, it's getting a little boring. 2 pi is 0 again? What's negative pi over 2? This would be negative pi over 2. What's it? Undefined again? And the next one would be a die. I could keep going, but this is getting very boring. All right, now, this is where you really got to put your thinking cap on. Any idea what shape is going to happen between these asymptotes? One of those what? Like those things, those squigglies that look like cubing functions? And that's exactly what happens. Now I want to explain to you why that is. But that is exactly what happens. Okay, and it just keeps going. Here's why. See this space right here between my fingers? That's 0 to pi over 2. That's here. What do you know about x and y here? Both positive. So when I build my tangent, won't it have to be positive? So in this space, I have to be positive. But in this space, which is here, the tangent would have to be negative, and then in quadrant 3 it's positive again, and so on. That is a picture of the tangent. What is the period of the tangent? Yes. I told you if you sat up, it would work. The period is pi. Look, kids, isn't this a piece? And isn't this the same piece? And the same piece? So isn't the period, that is the part of the curve that repeats, the chunk that repeats, just this little piece right here? So the normal period of the tangent is negative pi over 2 to pi over 2. So its period is pi. Now you could do 0 to pi, but it's a little more inconvenient because you don't have a smooth curve. You have the top piece and the bottom piece. So we normally just say this is my normal period. No amplitude. And if the frequency, if the period is pi, the frequency would be 1 over pi. Now, let's do the cotangent, last one, and then we'll do some messing around with them. What's the cotangent? Okay, well, I'm going to use the same circle, but cotangent is defined how? Not y over x, but x over y. So if I look at the same angles, pi over 2 pi, 3 pi over 2, 2 pi, just the normal regular angles, quadrantal angles going around my circle, tell me about the cotangent at 0. X over y. Undefined. So this one has an asymptote right here on the axis because y is 0. So you're going to have an asymptote. What happens at pi over 2? What is your cotangent? X over y. That's going to be 0. Uh-oh, are you sensing a theme here? What's going to happen at pi? Another undefined, 0, undefined, and go as long as you want to, I don't care. Keep in mind that the cotangent's the reciprocal of the tangent. The tangent is what we would call an increasing function. Would you agree with that? Only up. Well, if you take something that's only up and flip it upside down, then the values are going to not get bigger, but get smaller. So the cotangent is a decreasing function and looks like this. Now let me make sure you understand that. This is quadrant 1. Translate it to this picture there. Usually that is quadrant 1. X and y are both positive. Doesn't the cotangent have to be positive? That means it has to be up here. But in quadrant 2, it is negative. So you have positive, negative, and so on. What is the period of the cotangent? Pi? Isn't it the same as the tangent? Now, the normal period is not, we don't normally do negative pi over 2 to pi over 2. It's more convenient with the cotangent to do 0 to pi. Isn't that like a good piece right there? Just like this was a good piece for this one. Kids, you can pick whatever piece you want. But just to make it easier for all of us to converse, it's nice to have a standard piece to look at. So we'll look at that.
Do you have to write it like that if you write it
Right what?
period?
The period is pi. But the piece that we normally look at, so when we start graphing, changing it, putting numbers in it, this is the piece we're going to consider.
It's like when you look at how you're saying like pi over 2 to pi would be like
Quadrant
quadrant,
two.
it'd be like quadrant 2.
Mhm.
So that would mean that your x would be negative and your y positive.
Yep. That's why the cotangent's negative in that quadrant.
Because your x is positive. So
Your x is negative and your y is positive, yes.
but in like the picture itself, in like the curve itself, your x is positive. So is that why your y is negative?
Okay, your x here is theta. That's your theta. You are graphing cotangent values. So you are graphing x's and y's that correspond to the angle theta. Okay. Now, let's do some changing of the pictures by sticking in some numbers. All right, so number 2, let's do y equals negative tangent 2x. Okay, so what's happened? We got a tangent picture, which we kind of know what that is, or at least learning that. What have we done to our tangent picture? We've taken it and made it upside down. So this is kind of going to look like a cotangent. And we've also done what? Decreased its period by a half, right? So stop and think about that for a minute. Have we done any shifting? No, that's good. That's good news. So stop and think. We said when we graph a tangent, we are going to graph the piece of it that looks like this, right? And these are normally negative pi over 2 and pi over 2. Well, first thing we've done is turned it upside down. So now it's going to look like this. Would you agree with that? Second thing we've done is make it half as wide. So instead of going from negative a half to positive a half, it's going to go from negative a fourth to positive a fourth. Done. It's that easy. Gotta know what you're starting with. So you gotta know what a tangent looks like. But boy, if you do, that's easy. All right, let's try B. This one is a secant. So y equals 3 secant 1/2 x plus 1. So let's talk about what's happened here. What have we done? Well, we gotta be careful. I know I've times by 3, and for my cosine picture, that means the amplitude is now 3 for my cosine picture. I'm gonna start with a cosine here. So I'm gonna, in pink, I'm gonna graph 3 cosine 1/2 x. Start with that. Now, we should be able to do that. I'll do that in pink. Here we go. Is there any, I'm looking at just the pink one, is there any phase shifting? No shifting at all. So it's a normal cosine that looks like this. That's what cosines look like that aren't shifted. Because of the 3, this is 3 and negative 3, right? Normally, this would be what? In a perfect world, that would be 2 pi. But I have divided it by a half, so now it is 4 pi. And this one's 2 pi, and this one's pi, and this one's 3 pi. Old news, everybody with me with that? Now here's the problem. I'm not supposed to be graphing a cosine. I'm supposed to be graphing a secant. I know how to do that. To graph a secant, I just drop in some asymptotes, and flip my parabolas, right? So where will the asymptotes be? At pi, wherever I'm zero, wherever I cross the x-axis, this is a zero. And here. And then this is the weird one where we got the split pieces. There it is. Would everybody agree that what I have in black is this? So far, so good. Now, what do I need to do to my black picture? Move it up one. So now the parabola is going to start at 4. Now, it's not changing the asymptotes. It's not changing these labels. It's just moving everything up 1. So after all that, my answer is the purple. Easy? All right, let's get another one done. Sabrina,
What is the HS and DS?
what is
the
what?
S stand for?
Huh?
It says HS and DS.
Okay, that's vertical shift and horizontal shift. All right, so what do I got? Cotangent, 1/3 x. So before we start, what have we done? What changes? We know what our regular cotangent looks like. What have we done? Nothing, but made it 3 times as y. So we know we haven't shifted anything. So we know our cotangent has an asymptote here, an asymptote here, and decreases. This is a cotangent. In a perfect world, this of course is 0, and this is pi. That's how cotangents are. But what did we say we did? We divided the period by 1/3, which is the same as timesing by 3. So instead of that being pi, it's now 3 pi. And what's this one, right smack dab in the middle? 3 pi over 2, 1.5 pi, or 3 pi over 2. And that's it. Dang, this is so easy. All right, y is the big one now. Let's look at that. A lot going on. Here we go. What is it? It's a cosecant. So let's stop a minute. First of all, take that 2 out. We're not going to forget to do that. Just like with our sines and cosines, we have to take that, whatever that is there, we have to pull it out. Okay, so I'm going to pretend for a moment that this is a sine. So I'm going to graph y equals 1/5 sine 2x minus pi over 6. Okay. Now, what have we done? First of all, we've made it a whole lot shorter. So I'm not going to make it too shrinked up because then you can't see it too shrunk up because you can't see it on that video very well. So but that's only 1/5 and that's negative 1/5. This one is shifted. So please don't draw your regular sign like you would coming out of the origin. This one's going to start at pi over 6. So here's my sine curve starting at pi over 6. Phase shift. Normally, the length of this curve, that is the horizontal length of that curve, would be 2 pi. But what's happened? We divided it by 2. So now the length of that curve, distance from beginning to end, is only pi. or 6/6. So this is 7 pi over 6. I'm doing my sign first. Halfway in between 1 and 7 is 8, and half of 8 is 4. So 4/6. Remember, you don't have to reduce that unless you want to. Halfway in between 1 and 4, well, 1/6 and 4/6 makes 5/6, and half of that is 5/12. Fractions are our friends, don't panic. 4 and 7 is 11/6, and half of that is 11/12. That, guys, I was meant to do a pink, I'm sorry. That's my pink curve. Right? So now, I gotta make that a cosecant, so I'm gonna do what? Drop in my asymptotes. Wherever I cross the axis, those are the zeros, so the reciprocal will be undefined. Flip the curves. Voila. The red is the answer to the question. What is the amplitude of the red curve? Doesn't exist. What is the period of the red curve? Pi. Pi. What is the frequency of the red curve? 1 over pi. What is the phase shift or horizontal shift? Pi over 6. What is the vertical shift? 0 or none. You don't have one. Let's see. Right? Haven't moved it up or
When you're
down.
doing the vertical shift, do you include like the first number or just the last number?
Just the last number. The first number is amplitude. Shift is how you pick it up. What'd you say? It wasn't that bad. How about that?
I turned the page.
That turned out to not be so bad. Okay. So I believe that we may be able to finish all this stuff pretty much in one more class period. And maybe, so let me see, what's that look like? I see you again on Thursday.
Good afternoon,
And
people.
then Friday.
Great day. And to the educators, a special shout out and thanks to the mothers for a fantastic Christmas meal. Thank you, if there's any mothers still around. Let's end this day as
This
we
will
always do.
probably be Monday, it looks like, guys.
A reminder to please stay in your classroom until we're finished with prayer out of